Hello everyone, KJ4YZI HamRadioConcepts. Today I'm going to put together this high gain dual band VHF UHF Yagi antenna. So you may have seen this in a video before where I teased it and says, hey, this is what I'm going to use on my satellite tracker. This is the DB-2345. This is a multi-purpose, really. I mean, you don't have to use this just for satellite. You could use this handheld for satellite. You can mount it on a tracker. You can use this for VHF, UHF, dual band activities on D-Star, DMR, sideband, fusion, analog, repeaters in your attic. The thing about this is it's not that big, it's not that heavy, it's not that expensive. You can mount this in your attic and get yourself additional range. You may have a little something in your attic just because you live in an HOA to get on a local repeater, but something like this will fit in almost anybody's attic. Give you better range, better gain. 8 dB on 2 meters, 6 dB on 440, 3 elements on 2 meters, 5 elements on UHF. And this will extend your range. If you're talking about a repeater that's 30 miles away, you can put this in the attic. Even on a small rotator, it's light. So you can turn this with even a TV rotator, or you can do it the Armstrong method, put it on a little pole and kind of pop yourself up in the attic and turn it a little bit, or just face it north and work the repeaters in the north, or so on. So the high gain DB-2345, or 2345, excuse me, we're going to check this out, take it apart, put it together in the room here. It's raining again outside. I just cannot get away from this rain. And then in the future, when you see this on my satellite tracker, or if I'm out in the driveway or portable, waving it around in my hand with my handheld, this is what I'm using, the high gain DB-2345. Good for anybody that's wanting to get on VHF, UHF, or satellite. Remember, there's a ton of repeaters out there that people can't hit, or good repeaters that people don't know that are there. And something like this will get you back into the world of analog, or as a new ham, get you right into the action, even in an area where you're allowed to mount this outside and face it or rotate it different directions. Extend your range. Don't be the guy that can't make a repeater that's 20 miles away because you have an antenna that's in an HOA restricted area and you just feel like that's all you can do. Something like this will change that. Let's check it out.
HamRadioConcepts.
Now, always read your directions and, contents, package contents here, so you know what you're getting into. This one does come with a manual. That's essentially how it's going to look when it's finished, like on the picture, okay? And so it doesn't look like there's too much to do here, because looking at this right here, let me show you. This is going to be your boom length, okay, and that's very light. This is all like aircraft aluminum, so this is very light. Essentially, that's about as long as this thing is going to be. What's that? I don't know, 3 feet, roughly. Very light, so I can use it like this. It's not going to be that heavy on my satellite tracker, so the servos don't need to be extra heavy duty. But I wanted to try something else because I'm also trying the elk antenna soon and everything else. I wanted to see about, which one of these really does the best or fits my needs. So the little elements here, these are going to be, well, I could tell these are going to be the driven elements, right? And here's some elements here. They have color coding bands on there, so you can see that. It's got like purple and green and yellow, so you can identify which elements are going to go where. All right. It's also got, here's going to be your feed point with the ferrets on here. This is going to attach to the driven elements, and your SO239 for your antenna. Now, one thing I'm noticing already is it looks like we're going to use the same feed point for VHF, UHF, for VHF and UHF. So it doesn't look like there's a set of 2-meter driven elements instead of UHF. I got to figure out, see how that works. Basically, at the end of the boom here, whatever side it's going to be, probably this side right here, you'll be able to clamp this to a mast, like an inch or inch and a half inch mast, small one. Or maybe I could, like I said, use this as handheld like this and go waving it around like a handheld antenna. Okay, here's the technical specs. 144 to 148 megahertz is 500 watts CW or sideband. That's on 3 elements for 2 meters. The gain is 8 dBi. The front to back ratio is 17 dB. For UHF 420 to 450 megahertz, again, 500 watts at 5 elements, 6 dBi gain, 10 dB front to back ratio. And wind load is less than 1 square foot, weight is 2 pounds, the mass size is inch to 1.5 inch diameter. The overall length is 47 inches, so I guess that's way a little bit longer than my 3 feet I said. But here's the specs here in case you want to look at that, and it's also on the manual on the High Gain website here for the technical specs of this antenna if you're curious. Again, never mount this, of course, near any power lines where you can get killed. You know that, I hope. But one thing I will mention is, as an advocate with one eye, always make sure you got glasses on when you're handling elements like this, okay? Don't poke yourself in the eye. Very, very dangerous. So just make sure that you're not putting this somewhere where someone can walk into it. When you're putting it together, make sure that you have glasses on. I don't want to see anybody damaged by a Yagi antenna. So only thing needed for tools and assembly time, 30 minutes estimated. And the tools I need a 5/16 inch wrench, a 5/16 socket wrench, 3/8 socket wrench, and a pair of safety glasses, right? Because I don't need to read the manual to know that. I'm scared of sharp objects like that. So let's just go ahead and start putting this together and see, about the generic steps that I'll put this thing together with. Okay, so a couple things I already noticed. Number one, here is how the driven element attaches with that black piece here with the pigtail. So that's pretty much your driven element. At this point, right here, this would be considered a dipole for 2 meters. But we're going to go further than that. So this is your feed point, okay? And one thing I've noticed was there's only 3 screws in this entire kit, just for those pieces right there. Now, the manual states that these elements, all these different elements here for VHF, UHF, are held through the boom with push nuts, okay? So they go in like this, right? Push nuts. They're stainless steel, and I started questioning myself, like, whoa, what is this? Well, there are these little tiny things that come right here. Let me see if I can zoom in and show you. Okay, these are they look like those spider lock washers, whatever you call them. They're push nuts. So basically, there's a whole bunch of them here I have in a pile, but the difference between that and a lock washer that it tells you to use looks like this. One is a push nut and one is a lock washer. So what I accidentally did was switched them up. You use the lock washer for the screws and you use the push nuts for these elements. And basically, they're going to go on here, and you're going to push it through, and it kind of it's a little hard to get on there. And then you're going to push the element. It's a little tough that way. There, okay. So you can see it's on. They're on the little element here. This is just an example, and you're going to push the element through where it needs to be, see? Now that is going to then, you put a push nut on the other side and it keeps it from moving, okay? So we're going to go ahead and line the elements up and put them on in order the way they need to be on here. The longest will be in the back because that's the reflectors, and the shortest will be in the front because that's the director side. So the signal goes, to the end of the beam. That's how Yagi works. The driven element, and then you have a reflector behind it and a director in front of it. This is multi-element for UHF, so you have several directors in the front. And you could also do it this way. What you do is you take all the UHF elements, right? And now you can see which ones are the longest and the shortest. So essentially the longest one here is going to be the reflector in the back. And then the next one, you can see, is going to be this one. Right? So I line them out like this, that way I know which elements, okay? Number 3, it's like drawing straws, right? Longest straw wins. 3, 4, 5. And that's how I'm going to put the UHF elements in. Now when you're putting in these elements, the manual will tell you and specify how long each element needs to be from where it comes out of the boom to the end, okay? So the first one, the manual says 6 1/16 inch from one end. So then I'll take this before I put both the little push nuts on, and I'll measure it. 6 That's a 6 1/16 right there. I mean, it can't get any easier than that. So now that I have that in, and essentially it's the same on both sides out. You don't want it oblong on one side. So now I'm going to take another push nut. Wow, those are tough on there, huh? Yeah. Yeah, you might need a pair of pliers or a stronger set of fingers to get those push nuts on there, but rest assured, they ain't coming off once you get them on there. They got to kind of go on straight too. Man, those are tight on there. There we go. There we go. Okay, see? That element's not moving. Now, one thing I am noticing, okay? Well, I don't have this tight yet, but I can tell you that a couple of these holes look a little bit not straight. Okay, once I tighten this up, this one's a little not straight. So, what we're going to need to do is possibly bend this a little bit. We're going to get it together and see how far off they are. Might be able to, when I tighten these elements up here, line it up and bend just a little bit to get them straight. So like say I put the push nut on here like this. Okay, now watch. I'm going to shove it in here, the first one. Okay, and then you just kind of watch. Okay, get it where you need it. Right, measure it up. Second one says 5.5 inches. So I'm going to take this. It should be 5.5 inches one side. It's pretty good. Now, if you have one side, if these are not exactly where they need to be, like maybe it's a 1/2 inch longer, so balance it out. If it's 5 3/4 on one and 5 1/4 on the other, then you manipulate it so it's 5.5 on each side. So before I find out what this piece was designed for in the manual, I've been using it to put on these push nuts. These things are a pain. The first one's all right to get on. The second one, all I've been doing is taking this like this, and watch, I push it, and I slide it on like that. Because it really is tough with my little brittle fingertips to get those on there. And then I've been using screwdriver or a pair of scissors or whatever to just tuck that nut in there so that the element is tight. And I got to go through and tighten them all again, make sure that they're, you know, nice and solid in there. All right, a little bit of tweaking. I got that one about as best as I can get it. They're pretty much all in straight now, in line. That's compensating for the drill holes that are just a tad bit off. When you look at it this way, they're pretty much, I mean, besides the driven element that's not mounted in line, they're pretty much straight in line now, okay? So, again, not a big deal. I've had worse instances of this where they're not perfectly straight. I mean, you're really not going to, unless you're something like moon bounce EME or, you know, contesting 8,000 miles on 2 meters, that'll never happen. I mean, that's when you want to worry about that. If you're trying to talk to a satellite or a repeater that's not, you know, too far away, 40, 50 miles, that should be just fine. So let's put it on the analyzer real quick and just see what it looks like. Okay, so I'm going to try to do this with the one hand on holding the antenna out away from me and one adjusting the analyzer. So we'll start at 2 meters. Let's see here. We're going to go right about middle of the band here, I guess. Right about there. We're looking at about a 1 point, well, depending on how I hold it. Like, see if I go like this, you know, it goes way up when it, well, okay. So about right out there, arm's length, looking at, lowest is about a 1.3, I guess, 1.4. Okay, 2 meters. So if I was using satellite, it would be around here. It's about a 140 or 1.4 SWR. Now if I go up to UHF, I think I switched this here. Okay, so about 4, oh, I need to go here. Okay. It's really flat there, about 418. So right around 435, like sideband area, 1.6 roughly, 1.7. Go up to FM. FM 1.8, 1.9. Somewhere right there. So I'm not sure if that can be tuned. I'm going to set this down. I'm not sure if that can be tuned a little bit to adjust that. Maybe it has something to do with we're using one driven element for VHF and UHF, and the driven element's really cut for VHF, but it must be a multiple of the UHF. That's how that's working. So overall, though, the SWR is acceptable. And let me try. I'm going to hook it up to my little Anytone here. And we're going to try to see if I can hit just a couple distant repeaters on analog that I can't hit from here with a HT antenna. We'll see what happens. So here's what I'll do for a simple test. There's a repeater that's out in the Central Turnpike, probably about 40 miles from me, at least. And everything in between, trees, tree lines, houses, buildings, cars, interstates, and etc. So I'm going to try to hit that repeater and get a contact through it. It's a SARnet repeater, but I'm in Sebastian, and that's out the Central Turnpike, and I have just the Anytone handheld here at handheld power. I think it's, what, 7 watts? So we're going to try, oh, actually on UHF it'd probably be 6 watts. So we're going to try it out and see exactly if this thing makes a difference with horizontal versus vertical polarization, and also if it will enable me to make a contact. Let's try it out.
Other than that, I think he's got clear sailing all the way through Pensacola.
Let's see. I'll listen to the repeater here and I'll switch the polarization.
Yes, sir.
Okay.
That's Pensacola yet on radar. I'll have to switch over there and see what they're doing eventually. Have a good day. This is K4NRD. Take care. This is KN4 NOQ. Rescue.
K4NRD, KJ4YZI.
The station is just called K4NRD. I think the Y Yankee in your sign. Very noisy. I tried again.
Hey Pat, this is KJ4YZI. Can you hear me at all on this antenna?
I think that's Eric. I'm not sure. Very noisy, Eric. If that's you, KG4YZI, K4NRD.
Yeah, I'm trying a HT to the Central Turnpike with a handheld antenna, handheld Yagi. I'm just curious if I can make it that far. That's quite a trip. Over.
Yeah, Eric, if that's you, you're breaking in and out of the repeater now.
Okay, 7-3, KJ4YZI, Sebastian. So it's barely on the fringe.
Okay, got your call sign that time, Eric. KG4YZI, but a lot of noise in that signal. This is K4NRD, stand by the SARnet.
Yeah, very good. That's a handheld at 6 watts from Sebastian to the Central Turnpike with a handheld antenna. KJ4YZI, 7-3. If he heard that, then at least I know I made it. That's a long trip.
Okay, Eric, I think you said a handheld and Sebastian, but I'm not positive. We'll be standing by listening. K4NRD.
Okay, my arm's getting a little wobbly here because of my elbow holding an antenna. It's not that heavy, it's just that position. Okay. So anyways, that is actually impressive. So it is working. Now the next test is going to be with a satellite. As the satellite's coming over, me hitting it like this, you know, going over, we'll see what happens. Give my arm a break, but that's the whole point of building the tracker, so I don't have to hold this damn thing. But anyways, that is the high gain DB-2345 Yagi antenna. I'm probably going to, I got to straighten it a little bit more. I'm probably going to cement these in here so they don't rattle and move. And if I don't end up using it for satellite, I'll probably end up using it on the mast up there, vertical for FM. And I'm sure it would be a lot better than standing here in the driveway holding it a little more height. I'd do a lot better. So 7.3, more videos on the way. KJ4YZI.